All right, good news, bad news. No, that's not true. I can't lie. It's all good news, baby. There's only 2 more tests to go that I am going to teach about today. Well, the whole class. I'm done making videos after today. How exciting is that? So, the first one is the Wilcoxon Rank Sum. If you will, this is very similar to 2 things. Very similar to a T or a Z test, okay, between 2 samples. Okay? In terms of how we do it, is very similar to the Kruskal-Wallis test in that we're going to arrange them. For instance, let's say we had, well, one that your book uses, the Army and the Marines. I won't use their same numbers. I'll make up some different numbers, whatever. Okay? But what we'll do is just like we did over in the Kruskal-Wallis test a little bit ago, somewhere on this page we did it. We put all the A's and all the B's and all the C's. We'll have Army and then we'll have Marines. And we'll do the very similar ranking setup just the same way. And we'll also add up those pieces. That part will be 100% the same. It's only after that that things change a skosh. So this is just some numbers I'm making up. Your book, again, has an example similar to this. Not a big deal. You got to make some data up somewhere. So I'm just going to make it up. Now, it is important that you have at least 10 in each one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's cool. And then 17, 19, 14, 12, 16, 11, 12, 27, 18, and 9er. Okay? Now, I'm going to go ahead and whip up the Excel here because to me, I think this is always the way to fly on these guys. So here we go. And I'm just going to go ahead and kind of cut to the chase because I know there's no reason to type them in twice. In other words, I'm just going to go 14, 15, 1, 17, 19, 20. Nope, not 20, 10, dummy. There you go. 11, 17, 14, 15, 16. Okay, and all those are Army. Boom. Then we're going to go Marines. And then it's 17, 19, 14, 12, 16, and 9. And voila. Now, once we get it here, again, it's the exact same as we did with the Kruskal-Wallis. So equals rank dot average. Like so. We want to rank this point with respect to all of these numbers. Where does he fall in that range? And then do it in ascending order. Boom. And then I'm going to come down here. I'm going to add up the Army ones. So equals sum of the armies. Uh-oh. Shoot. How did I mess that up? Well, fiddly diddly fart. Let's try that again. It also works when you drag it up. Well, it should work when you drag it up. Oh, no, it doesn't. Well, we're going to try again. So let's try this again. We're going to rank B1. There we go. Wait, stop. And we're going to go from B1 to B20. There we go. What? Why do you hate me? Oh, because you didn't put a B1 there, dummy. There you go. I bet it works now. There you go. Now let's paste that baby down. There we go. So Army is here. So equals sum of the Army ranks. We'll do equals sum of the Marine ranks. Boom. Piece of cake. Now notice that they both had 10 in them this time. So the key here is that our test statistic will be test statistic this time. The test statistic will be equal to the sum of ranks from group with smaller sample size. Okay? In this case, it makes no difference because they both had 10. Okay? So either one will work. But if only the Marines had 12 and the Army had 10, I'd use Army because it has fewer. Okay? Now you're like, okay, well that's cool. So what do I do here? Well, Z equals, oh cool, it's a Z. That's right. It is. And so it's the following formula. It's R. By the way, this is your test statistic. So it's R minus. And then here's where it gets a little funky and wonky and weird. And you're like, well, that doesn't seem so bad. Yeah, just wait. Just you wait, friend. So the mean of the ranks, you find it by doing this. It's n plus 1 times n plus 1, or n1 plus n2 plus 1 all over 2. And that doesn't seem so horrible, but yeah, this is where it gets a little uglier yet. So it's the square root of, oh boy, n1 times n2 times n1 plus n2 plus 1 over 12. Yay! So, in our instance, both n1 and n2 are 10, and we know that because there was 10 in each column. So, that's 21 times 10 is 210, divided by 2 is 101. Oh, for God's sakes, what did I just do? 105. That'd be the mean of the ranks, is what that means. It's the mean of the ranks. Standard deviation would be, well, this again, 21 times 100, because 10 times 10 times 21, over 12, and then the square root of that. What just happened? Oh, for crying out loud. The square root of 2100 divided by 12, I said. There we go. 13.2 is my standard deviation. So, Z equals, if you come over here, I'm going to use 98.5. What you'll notice is that one of them is bigger than 105, and one's, oh, they're opposites. How cute is that? Now, interesting. Will they give me the exact same z-score, but one positive and one negative? No, they don't. What? That seems weird. It is a little weird, but that's how life goes. So, yeah, you would think in a perfect world, golly, it would be nice if that came out to be exactly the same distance apart. They aren't. So, I remember a time back in the day when I thought I'm going to really try to dig in and study why that is. And I remember the answer that I got. I was like, why did I waste time reading about that? Remember, these tests are not very powerful. Okay? That's what happens. You get, I mean, when you have to deal with what you have to deal with, that's what you have to deal with, and it's not very good. Now, negative 0.49. I don't think I need any critical values for that. I mean, for God's sakes. We know the critical value is somewhere near 2-ish on a z-score. Man, you're clearing here by the middle. That's ridiculous. You're 0, and you're right here. You're going to fail to reject. Fail to reject. Fail to reject what? Fail to reject H naught. Now, what am I saying by that? Well, I don't think I had an H naught. What would the H naught be here? Well, I was testing to see if there's any difference, right, in the time it took for, or in the time, or whatever it is, for them to be the same. So, when I say this, you know, there is no difference. You mean exactly like we did back in Chapter 9, Sections 1 and 2, in times for, you know, Army and Marines or whatever. Army and Marines. And so we failed to reject, so that's what we're saying. And of course, one is different. One is significantly different from the other. Okay? And it's quite straightforward. I mean, the test is pretty easy to do. It's not very hard at all. Now, We will be learning a second test that also sounds like Wilcoxon and sums and ranks and so forth. But here's the difference: Wilcoxon Rank Sum is for independent samples. Independent samples. Just like we did when we did 2 sample Z's and 2 sample T's. You got a group of people over here in Kansas, a group of people over here in Wyoming. Is there any difference? Blah, 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 blah. Okay? There's no relationship between them. They're not in any way paired up or with each other in that regard. They are what they are. Okay? Ooh! Let's do lefties and righties. And yeah, we'll do pitchers' batting averages though. So yeah, you get a bunch of these lousy batting averages. These guys that they couldn't even hardly get hit if they walked up there. They wouldn't even be able to hit the ball. Or, I mean, to get hit by the ball would be a trick maybe for them. But perhaps the lefties are a skosh better than the righties. There's Madison Bumgarner. He hits home runs. We didn't get that good average. I think Greg Maddux back in the day hit 250 or something ridiculous. I mean, but the rest of these guys are pathetic. What's the bet? Jay, you're a big talker. One more. This guy gets a hit 40 out of every 1,000 times he goes up to bat. Awesome. That's right. It is awesome. Now for the righties, it may be even worse. I don't know. I'll do one more righty. Because I can, that's why. There we go. And the idea here is that this time I do have a smaller one. One of them has a smaller sample size. So again, I'm going to whip up my Excel here and input the data and just try to speed our lives along with Excel because I love it so much. So lefties and then I'm going to, I don't know, maybe I won't. Now, I'm not going to worry about the extra decimal because they would have gone away anyways. That's just why we say it in baseball talk. It's hitting 65. Okay, so again, just like with Kruskal-Wallace, we're going to rank them, but Jay's going to remember to go to the top this time. So equals rank dot average. Voila. I want to rank this fella with regards to his population. F4 action. Did I hit it? Apparently I didn't hit it. There it is, comma 1. And then give him the old paste-a-rooney. Okay. Now, here's the end of the lefties right here. So equals sum. And then I could do equals sum. You can also use sum if you like. I prefer to just not. So I'm going to use the lefties. I'm going to use lefties because it was the smaller of the two sample sizes. That's going to be my critical value this time. So let's do the mean R. And the mean R is going to be equal to, parentheses, if you recall, it is n times, so n1, which was 10, times 11, oops, times parentheses rather, 10 plus 11 plus 1, right? Yes, sirree, Bob, divided by 2. And I forgot another parentheses right there. So my mean rank is 110, and my standard deviation is equals square root. See if I can do this all in one shot, because that would make my life so much easier. It's 10 times 11 times, and then it's 10 plus 11 plus 1, and then that whole shooting match divided by 12. I get 14. So then my z-score is going to be equal to, it equals the smaller of the two. So 130 is the smaller of the two of the sums of the ranks of the smaller of the two populations. There are fewer lefties than righties. So that guy minus the mean divided by its standard deviation, and I get a z-score of that. Well, now if we don't have this written down somewhere yet, but if I did, alpha, let's just say alpha was equal to 0.05, then we know that that would be plus minus 1.96 for our critical values, and so we would be rejecting plus or minus 1.96. We'd be failing to reject, which means there's no difference between righties and lefties when it comes to batting average. Okay? No difference at all. And that is the Wilcoxon Rank Sum test. Someone once mentioned to me is IRS. It's independent for rank sum. Okay? If that helps you, that's cool. If it's not, that's fine too. You're not going to hurt my feelings because I didn't.